Today we are looking at moment of a force under equilibrium. What is a moment of a force? The moment of a force, as you can see, is the turning effect of a force about a point. Like the turning effect created by that force about a particular point. And it is also the product of force and distance along the line of action of the force from that point. Like, let's consider this diagram on the board. If you look, this is just like a middle or a bar or a beam. So if you look at this, we can take moments about this point, which is the turning effect created by this force about this particular point. So when we take the moment about P, the moment of the force about P is equal to Fx, which is the product of force and the perpendicular distance from the line of action to that point. Look at the line of action of the force from here to here. Look at the point in which it is creating. We are taking our moment about. So the product of this force and along the line of action, which is this distance, we give you what? The moment of a force. But what if when that thing is inclined to a particular angle theta? If you look vividly well in this diagram, this is where the force is inclined to an angle. We look at here, the effective force creating the moment is this Fy. And if you look very well, you will see that this Fy, according to the distribution of forces, is equal to sine theta. So the moment of force about P will be Fyx. Why the Fy is m sine theta and the distance x. So when it is inclined to a particular angle theta, it is F sine theta then multiplied by distance, because the effective force creating the moment about that point is the force, the vertical force, which is the force along the y component. That is why we are using Fy. So know it, when it inclines to an angle